Today I want to talk about this fun combinatorics problem from the 1964 International Math Olympiad. Suppose 5 points in a plane are situated so that no two of the straight lines joining them are parallel, perpendicular, or coincident. From each point, perpendiculars are drawn to all the lines joining the other 4 points. Determine the maximum number of intersections that these perpendiculars can have. First, we should determine how many lines are going to be drawn. So let's just consider the point A. How many lines will be drawn from the point A? Well, we look at all the other lines that are drawn, and then we draw perpendicular lines from A to those lines. So the number of lines drawn will be 4 choose 2. And that is because there are 4 other points, and any 2 of those points you can choose to draw a line, and then you will just draw a perpendicular through that connects to A. And then we multiply by 5 because there are 5 points that we're drawing lines from. So the total number of lines will be 30. How many points of intersection can we create from 30 lines? The maximum number of points of intersection for 30 lines will be 30 choose 2. And that's because for any 2 lines drawn, they will intersect at 1 point. However, this is not the final answer, because if lines are parallel, no points of intersection will result. And if multiple lines intersect at 1 point, then there will not be distinct points of intersection, and we will be overcounting. So from this point, we count how many lines are parallel to each other, and we count when more than 2 lines are intersecting at 1 point. So let's count how many lines are parallel to each other and how this results in overcounting our points of intersection. So let's take any line, for example, EB, and we draw perpendiculars from A, D, and C. Notice that these 3 lines we've drawn are parallel to each other because they are all perpendicular to the line EB. So how many points of intersection have we overcounted from these cases? For any line, that is 5 choose 2 lines, there will be 3 lines perpendicular to that line that are parallel to each other, resulting in no intersections. And keep in mind that for these 3 lines, we counted how many points of intersection? We counted 3 points of intersection for these 3 parallel lines. So we must subtract 3. So the number of overcounted for lines that are parallel to each other is 5 choose 2 times 3, which is 30. Now we consider where multiple lines intersect at 1 point. The first obvious case is from the vertex themselves. The vertex themselves all have 6 lines coming out of them. And these 6 lines only intersect at 1 point, which is the vertex. So how many points are we overcounting for these 6 lines? Well, 6 lines originally could intersect at 6 choose 2 points. However, they only intersect at 1 point. So we've overcounted 6 choose 2 minus 1. And there are 5 of them total. So that is the number of overcounted points for the vertex. Are there any more points of intersection that are intersected by more than 2 lines? It turns out there is. For any 3 lines that form a triangle, for example, let's take A, B, D. When you draw these perpendicular lines, what do you get? You get the orthocenter of that triangle. For any triangle, if you draw their perpendiculars, if you draw their altitudes, they will intersect at 1 point, one distinct point called the orthocenter. So that is an overcounted case because 3 lines are intersecting at one point. For each of these that happen, how many times are we overcounting it? There are 3 lines, so we counted 3 points of intersection. However, there's only 1 point of intersection, so we overcounted 2 points. And how many of these are there? There will be 5 choose 3. Because choose any 3 points and you can form a triangle with those 3 points. So taking all the points we counted and subtracting the points that we overcounted, we get 30 choose 2 minus 30 minus 70 minus 20. And that should equal 315.